Maddie, what number did you find that went into 64 and 48? 16 was the biggest one. There you go. Alright, Kai, what's the only letter they have in common? X. There you go. Oh, Lord. I messed that up, didn't I? Alright, Abby, so when I take out a 16x, what do I have left? Okay. Very good. Very good. Alright, number 2. How many terms does number 2 have? 4. So you do grouping. Alright, look at the first two. What's the only thing the first two have in common? The A, right? So you have A and then A minus 4C. Alright, what sign do I bring out to the front? A positive, right? So positive, what's the only thing that these have in common? A B, right? So plus B. Take out a B, you got 4 minus A minus 4C. These have got to line up, right? If they don't, you did something wrong. So pull it to the front. A minus 4C. What's left? A plus B. There you go. Is that okay? Alright, what about number 3? Can you subtract any of those? Yes, no, maybe? Nope. Do they have anything in common? Nope. Alright, so you got to find factors of 32. So what numbers multiply through 32? 2 and 16. 8 and how much? 4. Anything else? 1 and 32. That's good enough. Alright, which one adds or subtracts to be negative 4? How? Somebody was saying something. Negative 8 plus 4? Very good. I'm going to do a negative 8 and a positive 4. Y'all okay? Am I lost? Okay. Let's do number 5 first because that's a little bit easier. This is from geometry, okay? Alright, what's this say? It wants the degree of angle A, which is this one. So these two are on a straight line. So how much does a straight line add to B? 180, right? So you've got, I just did that wrong. You've got x plus something is equal to 180. So how do I find that something? What would I do? How would I find this question mark? What do I need to move? The x, right? How do I move a positive x? You subtract it. So what's your answer? 180 minus x. Which one is it though? F. There you go. Are you okay with that? Alright. So let's look at this one. So you got, this month, Cammie sold 70 figurines in 2 sizes. The large figurine sold for $12, and the small figurine sold for $8. And the amount of money they received was equal to the amount of money he received from the sales. How much are the large figurines? So let's look at all our numbers. So what kind of numbers do you see first? $70. And the 2 sizes, right? Let's talk about the money, because the money's easiest. What did it say the money was? Money was equal, right? So how can I set my money equal? Where are my 2 money values? 12 and 8, right? But you got to put some letters with it. So 12 was the, which one, large? So I'm going to do 12 and L. And 8 was the small, so I'm going to do an S. Y'all okay with that? Alright, what's the other number it gave you? We did the 12. It gave you 70, right? 70 is the total amount that they sold. So if 70 is the total amount, then you're going to equal it to 70. And so what do I put on this side? Both the figurines together equal 70. So how do I do that? What are my two letters? L and S. And what should I do to those two? If both of them together are 70, what should I do to them? You would add them. There you go. Alright, so now there is a way to solve this, but that's what we're going to learn this week. So it wants to know how many large figurines did Cami sell, okay? So how can I figure that out? Using these over here. Soma?
Well, I divided them like here.
Uh-huh.
And 35 centimeters can be AB or D.
There you go.
And then,
Did y'all hear what she said? She said she divided 70 by 2, and that gave her 35. So she knew it couldn't be these three, because they were bigger than 35 and equal to 35.
and then I used to multiply the 20 and 12 and 8 and 8.
Alright, so she did 12 times 20. So this is awesome. You did a really, really good job. So what's 12 times 20? You've all got calculators, guys. 240? And what's 8 times 20? 160, right? And those don't equal, so the only one left is B. Very nice job, Selma. Very nice. Y'all okay? Anybody lost? They love to put these on the SAT. Alright, here we go. So let's look at your calendar real quick. You just got a new calendar. It was on your desk when you came in today. We didn't have school yesterday. Woohoo! So today's a typical Monday. Y'all are dead on me. Oh, wrong one. Sorry. Wrong one. Wrong calendar. Alright, so what do you have on Friday? A bell ringer test, okay? So here's what I want you to do real quick. I want you to grab your early bell ringers, like the bell ringers that we did the first couple of weeks. Hopefully you still got those. Hopefully you're not sleeping. A good grade on Friday should be really, really easy test on Friday. Alright, do you see these problems like this that Leslie has, where you're adding and subtracting? That's what your bell ringer test is going to be on Friday. That's it. All you got to do is add and subtract this stuff. Are y'all okay? Tyler, you got that? Okay. So make sure you find the ones that are like this, and make sure you know how to do these bell ringers. Because there's like 10 just on adding and subtracting. That's it. Yep, adding and subtracting like terms. So like right here, you would add these two because they both have x squared. So 3 minus negative 1 was 4. All right. So we're going to split chapter 3 into 2 sections, into 2 tests, which is why it's got 2 different learning targets on here. So the first thing we're going to do today is graphing, and then substitution and elimination. It's literally a review from Algebra 1. We're not going to do anything new yet. We're just going to review from Algebra 1 first. All right, so grab your first page. And I'll give you all a few minutes. I'm going to pause this and give you all a few minutes to get set up. All right, here we go. A system of equations. All right, I'm just going to go ahead and tell you this definition is going to be on your test and your quiz. So go ahead and make sure you know this one. A system of equation is 2 or more equations with the same variables. That's it. You need to know that definition right here. 2 or more equations with the same variables. Alright, so you got systems of equations can be classified by the number of solutions. That's what we're going to talk about. The first one, a system is consistent if it has at least one solution. So what do I mean by one solution? Here you go. You might want to write this down. You ready? If it's got a one solution, that means that when you graph them, they cross at one point. That's why it's called a one solution. So this one's called consistent. All right, what else we got? So if it's one solution and it's inconsistent, if it has no solutions. So what do I mean by no solutions? They never, ever, 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 ever cross. So if they never cross, then they are parallel. So that's inconsistent. You might want to make sure you draw that little picture up there at the top, because that helps most people better than these words do. Alright, so if it's consistent, then the system can be independent, or it can be dependent. So let's talk about which one's which. So if it has exactly one solution, so if it looks just like this picture, if it's one solution, then it's independent. So let's go to our picture. So this, if it crosses at one point, we call it consistent and independent. Alright, so if it's infinite number, what do I mean by infinite? That means every single point is the same. If every single point is the same, then that's the same exact line. So the two equations come out to be the same line. Then it is dependent. So if it's the same line, we call it consistent and dependent. I have this little drawing because it's going to help you. Sir? Yep. So like right here, you see how you have two equations? And when you solve them for y, they come out to be the same exact equation, which is the same exact line. I'll show you when we get to that one here. Alright, here we go. So we got a graph. So when we graph, what letter does it have to be solved for in order to graph it? Huh? Y. There you go. So let's take the first one. Let's take this first equation right here. Alright, what do I got to do to solve this for y? Subtract the x. There you go. Same thing we've been doing, right? X comes first, so it's negative x plus 6. Then what I do? Divide by 2. Divide everything by 2. Alright, so you got a 1 right here. So this is negative 1/2 x. And then what's 6 divided by 3? Excuse me, 6 divided by 2. I'm sorry, y'all. That gave me 3. I just gave you the answer. Alright, so I got to graph it. What do I do? B for beginning. What's my B? Positive 3. So I'm going to go up 3, put a dot. What's the negative 1 tell me to do? Down 1 and the positive 2? Right 2. Don't say over, because it's going to be right or left. Alright, what's the opposite of going down right? Going up 1 and left 2. There you go. And you need to make these pretty big, because if you don't make them pretty big, then you may not see where they cross. Alright, so what do you got? You got an equal sign, right? So if you got an equal sign, they're always going to be solid lines. Remember that dotted and solid line stuff that we did right before we took a test last week? I know y'all slept since then, but... Alright, let's take the other one. Here we go. Gotta solve this other one for y. Alright, what would I do first? Subtract 2x. So y equals, x always comes first, so negative 2x plus 9. What's my b? Where am I going to begin? 9. 1, 2, 3, 4, 5, 6, 7, 8. Let's just do 9 up here. Alright, what's my slope? Negative 2 over 1. Negative 2 tells me to go down 2. Positive 1, bless you, tells you to go right 1. Alright, and we got to do it until they cross. So keep going down 2 and right 1 until they cross. And right there, that's where they're going to cross. Okay. Which one of these does it look like? First one, second one, or third one? The first one, right? So it says, then describe if it's consistent and independent, consistent and dependent, or just inconsistent. So which one is it? If they cross one time, what's it called? Consistent and independent. There you go. Perfect. That's all you do. Alright, let's look at number 2. Alright, I gotta solve it for y. So what would I do on the first one to solve it for y? This one's easy. Add x. X always comes first, so y equals x plus 5. Alright, what's my b? Cindy B, let him in. What's my b? What's my b? 5. So I go up 5, right? Alright, what's my slope? 1 over 1. So I go up 1, right 1. Or down 1 and left 1. Now remember, make it pretty big. Because if not, you might not be able to see where they cross. Tyler, just catch up on number 2, okay. It says graph, so we gotta solve them both for y. Alright, let's see. Allie, what would I do first to solve this one for y? Perfect, perfect, perfect. So x comes first, so I got 2y equals 2x plus 8. Divide by 2, Erin? Everything, right? Divide everything by 2. Alright, so y equals x plus 4. So what's my b on this one? Where am I going to begin? 4. And then what's my slope? 1 over 1. Alright, so they're really, really close together, so make sure you use those lines. So I can go up and right, or I can go down and left. Are they ever going to touch, though? No. Alright, so Tyler, you may want to get this real quick at the top. Ready? Those 3 little drawings. I think you missed that. So which one does it look like at the top? The first, second, or third one? The second one, because they are no solution. So what do we call it? Inconsistent. There you go. Pretty easy, right? Consistent and dependent. Make sure you've got these, guys. If you don't, you're going to be hard up on these problems. Alright, if you finish, go on to number 3. Just inconsistent. If it's, see, like right here, if it's parallel, then there's just that inconsistent. There's nothing else. Huh? Say that again. How did you get this? Okay. Where at, Jacob? Yeah? Yeah? Then we gotta get rid of that 2, so you finished, Tyler? Okay, alright. Yeah. Divide by 2. We got 8 divided by 2. Which is 4. And you get the graph? Yeah. Uh-huh. And then I graphed it. I went up 4, and then up 1 and right 1. Alright, y'all try 3 real quick while we're waiting on a few people to catch up. Good, Tyler? You good? Jacob, you good? Did you get that they were inconsistent? Okay. Alright. Alright, so we gotta graph them, so it means we gotta solve for y. So Peyton, what did you do first to solve that top one for y? Perfect. Alright, so when I subtract 3x, I got 2y equals negative 3x plus 12. Alright, Hunter, what would I do from here?
By both sides by 2x.
Everything by 2, right?
2.
There you go. Alright. So 2's go away. These cannot divide, but that's okay. You want your slope to be a fraction, so just leave it alone. And then what's 12 divided by 2? 6. So I'm going to go up 6. 1, 2, 3, 4, 5, 6. Alright, what's the negative 3 tell me to do? Down 3 and the positive 2? Right 2. Perfect. Make sure you go pretty big so you can see if they cross. Alright, Reagan, what would I do on the second one to solve it for y? You would subtract x. Perfect. Alright, when you subtract that x, 2 is negative, so make sure you keep it negative. Alright, Sydney, what would I do from there? Careful. Perfect. Divide everything by negative 2. Alright, negative 2's go away. So y equals, what happens to these negatives? They cancel out, become positive, and this is 1 over 2x, so 1/2 x. And then what's 4 divided by negative 2? Negative 2, there you go. So I'm going to go, b is negative 2, so I'm going to go down 2. Alright, what's this 1 coming to do? Up 1, and this 2? Which way? Right, there you go. And looky there, they're going to cross right here. Alright, so put back on the other page. Which one does that look like? The first one, the second one, or the third one? The first one. So what do we call it if it's the first one? Consistent and independent. There you go. Infinitely many solutions, it's the same line. It comes out to be the same line. So like when we go to solve these, they're going to come out to be the exact same thing. Which should be number 4, since it's the last one, and we haven't done one yet. Alright, here we go. Alright, take the first one. Let's see, so what would I do on the first one to solve for y? Minus 4x, perfect. Alright, so look right here, that 2 is negative, so make sure you keep that negative with that 2. Alright, Jonathan, what would I do after that? Perfect. So, what's negative 4 divided by negative 2? Positive 2 or negative 2? Positive 2. Alright, Michael, what's 6 divided by negative 2? Negative 3, perfect. Alright, so I'm going to go down 3. What's my slope? 2 over what? 1. So I'm going to go up 2 and right 1. Make it pretty big. Or I can go down 2 and left 1. Alright, what about the bottom one? Let's see. Tyler Emerson, what would I do first on this one? Perfect, perfect, perfect. Alright, so that 3 is negative, so be careful, okay? So negative 3y equals negative 6x plus 9. Alright, Maddie, what would I do from here? Perfect. Divide everything by negative 3. Perfect, perfect. Alright, what's negative 6 divided by negative 3? 2x. What's 9 divided by negative 3? Negative 3. Do you see how they come out to be the same exact thing? Y equals 2x minus 3. Y equals 2x minus 3. Do I have to graph it again? No, it's the same sticking line. So which one's that? The first one, second, or the third one? That's the last one, right? And so what is that? That's consistent and dependent. There you go. Pretty easy, right? That is literally a review from Algebra 1. If it's not, then I just taught it to you again. It's not a big deal. Alright, if you got a highlighter, you might want to get it real quick. We're going to do 1 and 2, and then we'll call it a day. We're going to do 1 and 2, and then we're going to call it a day. Alright, I got a couple of extra highlighters. Anybody want one? Anybody want one? I got some more. I got one more if anybody wants it. One more? Okay. Alright, here we go. So, what's the directions say to do? Solve how? By substitution. We're doing the exact same thing. We're trying to find out if they're the same line, if they are parallel, or if they cross somewhere, okay? Alright, so substitution, you got to find a letter by itself. You might want to write that down. Alright, look at number 1. Do you have a letter by itself? You got x by itself, right? What's x equal? Negative what? 5y, keep going. Plus 3. That's what I want to highlight, okay? So you want to highlight that part. And then I want to, on the next equation, where do I want to plug that into? If this was equal to x, then I want to highlight my x. So that's where it's going to go. Alright, now grab your pencil back. So we're going to follow this bottom equation. We're going to write a 3. But then we're not going to put x. We're going to put what x equals. What did x equal? Negative 5x plus 3. There you go. Huh? Oh, that's negative 5y. I'm sorry, that's negative 5y. My bad. And then keep following that equation. Minus 2y equals negative 8. There you go. Do you see how I only have one letter? I only have y? So now I've got no choice but to solve for y. So what could I do to solve for y here? Multiply everything by 3. I could distribute that 3. So that'd be negative 15y plus 9 minus 2y equals negative 8. Alright, what else could we do? Alright, what's negative 15 minus 2? Negative 17y. And then bring down your plus 9. Bring down your equals negative 8. Now what can I do? Subtract 9. So 17y equals negative 17. Now what could I do? It is. Oh, that's positive 17. Is it? No, it is negative. I'm sorry. I didn't see that negative. Thank you, Jack. I didn't see that negative right there. Make that bigger. Alright, now what can I do? Divide by what? Negative 17. So what's y equal? Positive 1. Alright, but you're not done yet. You got to figure out what x is. So how could I use this to figure out what x is? Plug it in, right? So here we go. X equals negative 5y plus 3. That y is going to go right there. Alright, so we got negative 5 times 1 plus 3. That's just negative 5 plus 3. That's negative 2. So what's your order pair? And 1. There you go. That's your answer. What does that mean? That means if we were to graph this, just like we did the other ones, they would cross right there at negative 2, 1. So you have a graph that looks like this. They would cross right there at negative 2, 1. Are y'all okay? Alright, number 2 is going to be your homework, but I'm going to help you out on it. Alright, I don't have a letter by itself. So I can make it have a letter by itself. It doesn't matter which one because I'm not graphing. So do you want to solve for x or do you want to solve for y? You want to solve for x? Okay. So I'm going to subtract that y. It doesn't matter. It only matters when you're graphing, okay? So x is equal to 12 minus y, right? So what am I going to highlight? What's the letter by itself? 12 minus x. There you go. Is it negative? Oh, it is, isn't it? I didn't see that. Thank you. Negative 12. All right, and so then I'm going to highlight it's equal to x, right? So that's why I'm going to highlight this x right there next to that too. Negative 12 minus y. All right, so we're going to plug it in. What's your first thing you see? 2. And I'm not going to put x. I'm going to put negative 12 minus y. And then minus 3y equals 6. There you go. So that's your homework tonight, is to finish solving for x and y. Y'all good with that? It's your first homework assignment of the second quarter. Make it good. Make it good, make it good. Alright, we got, what, 3 minutes left? You get here at 9:02, is that right? 9:04. Okay, so y'all have 4 minutes left. 5 minutes left. Alright, so you got 5 minutes left to finish getting this solved. I am going to come around and check it tomorrow. If you got my highlighters, bring them back, please, so you can use them again tomorrow. Thanks, ma'am. Yeah. Thanks, sir.